about examples 2 and 3 here. And remember that we were trying to decide what kind of a figure it is just by looking at the equation, not by doing any kind of simplifying, not by getting the standard equation, nothing like that. We're just looking at the equation as it stands. And so we're trying to figure out what the last two are. Process of elimination says that it has to be a circle and an ellipse. But let me tell you, I don't fall into that, okay? Now, I will say I did do one of each. But on the test, it's not necessarily that you're going to have one of each. I wouldn't have a problem with doing 4 questions. 2 of them are the same type of figure, just to throw you for a loop, okay? To see if you really know what you're doing. So don't just say, well, 2 and 3, they have to be a circle and ellipse because we haven't done those yet. Bad reasoning, okay? But they are, just because I'm working examples. So talk to me about your thoughts on these two. We had started having a discussion about it. We ran out of time. So what are your thoughts about which one is the circle and which one is the ellipse? What was the mind-blowing thing I said at the very end of the class period? Yeah, a circle equation can actually be turned into an ellipse equation. And what that means is that circles are ellipses. What? It's just a special case scenario, right? So think about an ellipse. Talk to me a little bit about the numbers on an ellipse, or the letters. What are the 4 letters that are the most important for the ellipse? H, K, A, and B. What do A and B do on the ellipse? A does what? Okay, it is on the major axis. Okay, what about the vertex? Good, it's the distance from the center to the vertex. And what's B? Distance between the center and the, what did you say? The end of the minor axis, yeah. So, okay, so let's just pretend for a minute that we're looking at a circle, okay? If you go right and left on a circle, and if you go up and down on a circle, it's the exact same. So if a circle really is a special case ellipse, what do you know about the A and the B? They have to be exactly the same. Okay, now let's take that a step further. Okay, I don't want you to start getting a standard equation, so don't write this down. But what if I were to divide every one of these by 36 and started getting a standard equation? What would you end up with? And in this case, are my A and my B the same? They're not. So this would have to be what? It would have to be an ellipse. Okay, so I'm going to erase this because I want to try to figure out how to do this without the aid of doing any of that math work. Okay, let's take a look at this one here. Okay, so let's do just a little bit of work. Again, you can just watch me do the work because I'm going to erase it. What would you do if we were going to get the standard equation? Okay, so I factored out a 3, and I would be left with right? And so take half and square. Okay, so that's going to be a +4, and what am I going to add to the other side? So this is going to be 3 times the quantity plus 3 times, it is a y squared, but can you think of it like this? Y plus 0 squared is equal to 12. Okay, and then what would you do? And so this is going to be x plus 2 quantity squared over plus y squared over equals 1. Okay, now look at your a and b. They're exactly the same. Okay, now wait a second. Okay, so I'm going to get rid of all this. Let's go back and look at those two equations. What is it in the original equations that caused a and b to be different on the first one, but a and b are identical on the second one? What do you think?
The second one constant.
The second one has a constant? Where? Oh, example 2. Sorry, when you said second one, I thought you meant second one on the page up there. Apologize. Yeah, so 36 has a constant. Yeah, but when I did a little bit of work, example 3 had a constant. It had a 12. Remember that? Okay, so that's not what's different. What are those called? Do you remember? Starts with a coefficients. Look at the coefficients on example number 2. Look at the coefficients on the squared terms on example 2. Look at the coefficients on the squared terms on example number 3. What do you see? What about for the first one, for the example 2? They're different. So that's what caused me to have a different a and b, because think about it. When I was dividing, I had 2 numerators that was different. So when I divided by the same number, I ended up with a different denominator. But yet in the third example, when I was dividing, since my numerators were the same and I was dividing by the same number, that's why I got an identical a and b. Okay, so let's figure out what is it. Ms. Roberts, what do you want me to write on the test? I mean, that's what really everybody wants to know, right? Okay, so for example 2, what kind of figure was it? It's an ellipse. Example 3 is a circle. And now for a short explanation. Okay. Okay, so that's part 1. These two actually require a 2-part explanation. Okay, so part 1, coefficients on squared terms are different. Coefficients on squared terms are different. Okay. And then for the circle, what could we say? So here's another way to say it. X squared and y squared coefficients are equal. Just trying to write it in a couple different ways so that you can see that it's still the same thing. All right, this isn't sufficient though. Can I show you something? Come down to number 4. Look at the coefficients on the squared terms. Are they the same or are they different? They're different, but we didn't say it was an ellipse just because they're different, right? So I can't use just coefficients are different for an ellipse. I need a little bit more. Okay, why isn't this one an ellipse? Coefficients are different. oh, one of my squared terms is negative, right? That's what made it a hyperbola. Well, then what makes it an ellipse? What's the extra piece of information that makes an ellipse? Yeah, my squared terms are positive. So you ready? This second part is really easy. Coefficients on squared terms are different and pause. Same thing for the circles, because I could have coefficients on the hyperbola that are the exact same number. So it's the same thing here. On the circle, coefficients on the squared terms are equal and positive. So I need to have both pieces of information to be able to say it's a circle or to be able to say it's an ellipse. Any questions on that? Okay. Number 4. Last section. It's parametric equations. Parametrics are something that we need to introduce you to them. I'm not going to spend a lot of time in it. Like I said, maybe it's a 20-minute discussion, maybe. Parametrics, though, are something that deals with our old x's and y's, and then it throws in the concept of time. Okay, so that's the T that you see. All right, we're really only gonna scratch the surface of parametrics. I'm not gonna do a whole lot with you on parametrics. Basically, it's just kind of introducing you to the topic. Okay, so there will be a question on your test that deals with parametrics, but it won't be a majority of your test. Okay, so what we have here, I'm told several things. I'm told to fill in the chart. I'm told to graph. I'm told to find a rectangular equation. What? Okay, so anytime you see the word rectangular, this automatically means your old equations that just have x's and y's in them. Okay? Old equations that have, so in other words, it's what you're used to. When we get into chapter 11, which is way down the line, chapter 11, we'll talk about rectangular stuff, x's and y's, versus polar stuff, r's and thetas, okay? But that's not until chapter 11. All right, so you'll see that word again, but by the time we get there, you probably will have forgotten that we saw it the first time, okay? So rectangular just means x's and y's. All right, so let's go ahead and take a look at the things that I've been given. Notice that I was given an x equation in terms of t. I was given a y equation in terms of t. And then I was given a restriction on t. Okay, do you see how it says T and then there's that funky looking E? That's element of. So it says T is an element of, and then it gives you an interval. In other words, all of your T's fall inside of that interval and you're not allowed to go outside of that interval for your T's. Okay, so you can have a T value, and you can see here that in my chart, I've started to list some T values. There's not only 3, there's an infinite number of T values. Like I could have a negative 0.9 and a negative 0.99 and a negative 0.999, negative 0.9999, and I haven't even gotten to the 8s yet, right? So I have an infinite number of T values. I've just chosen the 3 pretty ones, okay? All right, so now that I know T, let's go find our X values and let's go find our Y values. All right, and so if you plug in a -1 for T into your X equation, what do you have? 1. If you plug in a 0 for t on the x equation, you get 2. And then if you plug in a 1, you get 3. Okay, it's not rocket science. Let's do the same thing for the y's. Plug in a -1 for the t on the y equation, and you get 1. Plug in a 0 for the t, y is 0. And then plug in a 1 for the t, y is 1. Now, what you have for a graph, this is actually your rectangular axis. It's your old x and y axis. Okay? And what you've just done, when you found those x's and y's, you found 3 coordinates that you can graph. All right? So the first coordinate then, let's put some numbers on our graph. Now, I'm going to spread things out because the largest number up there is a 3. So I'm going to go 1, 2, 3 on both x and y. And just spread it all out. So you have 1, 1. You have 2, 0. And you have 3, 1. Okay, I know I'm supposed to connect the dots, but I don't really know if I should connect the dots with straight segments, like making a V graph, or if I should graph them with curved pieces. I don't really know. So going back to the directions, finding my rectangular equation is going to help out with this. So remember, a rectangular equation is an equation where there's only x's and y's in it. You can't have any t's, okay? Both of the equations that I was given, these guys, these are not rectangular equations, they're parametric equations. They have a t in them, okay? So we want a rectangular equation. Well, if you take the first equation, can you find out what t equals in the first equation? Yeah, t is equal to x minus 2, just by rearranging. Well, now that you know what t is, can you take what t equals and go plug it in for the other t value in the other parametric equation? Let's take the other parametric equation, and we'll have y equals, okay, what's my t now? It's an x minus 2. So there's my t, and what am I supposed to do with the t according to that original parametric equation? Square it. Oh, okay, so I've done 2 things. First thing is that I got my rectangular equation. Okay, that's what the directions said to do. But now the second thing is because of what we know in Math 110, we know what that looks like. What does that look like, that equation? Yeah, it looks like a parabola. Okay, so now I know that on my graph, I'm gonna draw a parabola, but wait. Remember, you were restricted on your t's? So yes, this is a parabola, but you can't draw the entire parabola. You can only draw the parabola for the t values between -1 and +1. So it's not your normal everyday parabola that goes on forever and ever and ever. Okay, this one was restricted to a certain interval. Okay? All right, you guys have your calculators today? Pull those out. Turn it on. Okay, what I want you to do is I want you to go to mode. Mode. Look at the 4th line. What is your black box around on the fourth line? On the fourth line? Yeah, you've got an extra line. So yours is, okay, so if you have a, it's either the fourth or the fifth line, and it's not the one that says radian and degree. Some of you have it, it's on the fourth line, and some of you it's on the fifth line. Mine's on the fourth, okay? So what's your black box around on either the fourth or the fifth line, but not radian? Function, okay? What's to the right of that? PAR, what do you think that stands for? Parametric. What do you think the third one stands for? Polar, that's actually what I was just talking about, chapter 11, okay, so it's down the road. Let's go into parametric. So I want you to change your mode into parametric mode. All right, go ahead and do second quit, get out of that. And go to your y equals. Whoa, why whoa? What looks different? What is it? Oh goodness, well there's x's, y's, and t's, right? This is funky. Okay, so what you're gonna do is you're going to, let's type in t plus 2 for the first equation. It says x1t equals, let's type in t plus 2. Hey, question before you start typing. Where did you used to find the button that had the old x on it? Where was the button that you, when you used to type in a normal equation like x squared plus 3, where did you type in that x? What button did you use? One beside alpha. Now, will you look at that button? What's the second letter on it? Push it, see what happens. Oh! Hey, look, what's the third letter on it? Theta. It's a Greek letter. That's going to be used for polars. Okay? Back in chapter 11. Okay? All right. So go ahead, type in t plus 2. And then enter down and type in t squared for your y. Okay? Now, before you start graphing, go to the window. Go to the window because we have to give t a restriction. What is our restriction on t? What is it? Yeah, -1 to +1. Okay? So let's go ahead then. Where it says t min, let's put in -1. Where it says t max, let's put in +1. You don't really have to worry about the t step. Okay? X min and max, y min and max are your set right now on -10 to 10. So basically what you're going to be graphing is a domain from -10 to 10 and a range from -10 to 10. And that's fine. That's fine. Okay, so now go ahead and push graph. You got an error. Did you use the minus sign when you typed in a negative on the -1, or did you use the negative, which is down to the left of the enter?
Still gave me an error.
What's the error say?
Invalid.
Yeah, I think it's in your window. So go back to your window, Savannah. What's your t min?
-1.
And did you actually use the negative symbol? And what's your t max?
1.
And then go on down. What do you have in there for x min and max, y min and max?
-10 and 10.
And push graph again. See how I got a box around the plot up above? Get rid of that. So arrow up, push enter on that box, and now push graph. Yeah, it was trying to plot something, but you didn't have anything to plot. So it was struggling. Yeah, okay. Do you have something that looks like this? Well, yeah, if you get a magnifying glass out, right? How could you fix being able to see it a little bit better? Yeah, your X min and max, your Y min and max. That would be one way to change it. So maybe you only want to look at, let's say like from 0 to 4 for your X min and max, and from maybe -1 to 2 for your Y min and max. And that's going to really zoom in on that. You can use the zoom function. Sometimes that works and sometimes it doesn't. Sometimes it works well and sometimes it doesn't work very well. So were you able to see it a little bit better when you changed the window? Yeah, yeah. Okay, so we can graph parametrics then on the calculator. Let's go to number 2. It's almost more tedious to graph these easy ones on the calculator. It's almost easier to graph them by hand, but it's nice to have a backup. Okay, so what's your first X value? 1, your second X value, and your third X value. 1. Now, before I go any further, there should be a red flag for you. There should be something that's really bothering you right now. What's that?
T is -1.
Yeah, what's wrong with that? It was fine for the last question. Okay, so that's one thing. You're on the right track, you're just looking at the wrong piece of the paper. Why is it a problem that T is -1? What does the restriction say? 0 to 4, -1 isn't even there. Let's fix our table. Let's fix our table. Okay, so we can get rid of this guy because it doesn't even matter. It's not in our restriction. But we will need maybe like a T value of 2 and a T value of 3 and 4 maybe. We don't have to have all those. So now, what's the next X value? Okay, and then after that, and then, okay. Now let's go over to our Y's. So what's my first Y value? 0. The next Y value? 1. What's the next Y value? Don't type it into the calculator, just tell me what it is. Square root of 2. Square root of 2. What's the next one? And then the last one? 2. Now, when it comes to graphing, I'm only going to graph the 3 pretty ones. I'm going to ignore the other ones. Okay? So I'm going to graph 0, 0. I'm going to graph 1, 1. And then I'm going to graph 16, 2. Okay? Now, if I'm going to graph 16, I shouldn't be spreading things way out, right? I don't even know if I have 16 blocks. Nope, I've only got 9. So I have to go by 2s. Now on the y-axis, I'm just going to go by my normal 1s because my y values just are 0, 1, and 2. Okay, so we got our first coordinate is 0, 0. Our next coordinate is 1, 1. And then our last coordinate is 16, 2. Would you say that that's like one straight segment? Do those line up, all three of them? I don't think so. But let's go back and let's see if we can get our equation. Okay? Let's see if we can get our equation first. Now, remember that the first time we did this, step 1 was to solve for t. Take one of the equations and solve for t. Okay, so which equation would you like to solve for t on? Eeny, meeny, miny, mo. How about the y equation? You say, why did you pick that one? I don't know, I just felt like it. How are you going to solve for t on the y equation? Yeah, you would square both sides. And so what would you get? Y squared equals t. T equals y squared. And what will you do with that? You'll plug it into the other equation. So this will be x equals, okay, I'm not going to write a t. What am I going to write? Y squared. And what will I do with that y squared? Square it. So this is the same thing as x equals y to the 4th. Now, usually when we write a rectangular equation, do we usually have an x equals or do we usually have a y equals? Yeah, it's usually a y equals, okay? So how could I get y by itself? I could use a 4th root. Can you think of another way? What's the same thing as a 4th root? You learned this in Math 110. Yeah, a 1/4 power, okay? And so you could take the 4th root of both sides, or you could just say, well, let's raise both sides to the 1/4 power. Because y to the 4th to the 1/4 just gives you a y, and then this is x to the 1/4, or 4th root of x. Either one is okay. Can you picture a 4th root? Probably not. Can you think back to Math 110? In the library of functions, you had to graph the square root graph. Do you remember what the square root graph looked like? It was the one that started at the origin and it went whoop. Remember that? Yeah. Well, this is the same thing, only it's just stretched out a little bit more. Okay, so that'll help us with graphing. It looks like the swoop. The difference is make sure you stop on that coordinate 16, 2. You can't take it any further. Remember, there's a restriction on your t's. Okay, so if you wanted, you could go and you could see if your calculator gives you the same graph. I'm not going to take the time to do that, but you could do that if you wanted. Okay. All right. Any questions? I'm going to talk about the test here in just a moment. Any questions, though, on material content that we covered today? Okay. Talk to me about the unit circle. I told you I was not going to teach you the unit circle, but I didn't say that you couldn't teach it. Okay, so talk to me about the unit circle. All right, so we can use either radians or degrees. When we get into chapter 9, you're going to find that radians and degrees are kind of like measuring distance in miles versus kilometers, right? Miles and kilometers are 2 ways to measure distance as you're driving. Degrees and radians are 2 ways to measure angles on the circle. Okay, so it's 2 ways to measure angles. There's more to it than that, but that's the rough draft version. Okay, so we can have degrees or radians. So let's focus for a minute on degrees because that's the one that we're more comfortable with, right? What were the 3 ways I taught you on the video to count using degrees? Was it 3 ways? I don't remember. Dylan, I think it was 2 ways.
Quarters or slices and I forgot the third one.
It's okay, so let's talk about degrees. Okay, so what numbers were you counting by in degrees? Okay, so we were counting by 45s, and that got you all the way around the circle, right? And then we went back and counted by 30s. And if you can count by 45s, and if you can count by 30s, you get every single position on the circle, okay? This is like, you remember how in 3rd grade math, you guys learned how to count by 5s? 5, 10, 15, 20, 20, do you remember that? Right? Same idea, only now we're counting by 45s, or we're counting by 30s. Okay, same concept. All right, by the way, all the 30s, what did they land on? On the picture that I provided for you online. Like a spoke, right? Didn't they all land on one of the lines of the circle? Where did the 45s land on, most of them? It was smack dab in the middle, right? But it didn't have a spoke on it. Okay. Okay, so we counted by 45s, we counted by 30s. Okay, so let's go over to radians then. In radians, we did the same thing, except that our numbers were different. The positions were the same places. So instead of counting by 45s, like we did on the degree, what did we count by on radians? So listen to my question again and look at your unit circle. Instead of counting by 45s, we counted by 4ths, right? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, right? Okay. Instead of counting by 30 degrees, how did we count in radians? By 6. 1, 6, 2, 6, 3, 6, 4, 6. What did I do along the way for both of those? I reduced my fractions. When I was counting by 6, when I reduced, I didn't get 6. What did I get? No. 3s and, look at the top one. Yeah, 3s and 2s, right? I got either a pi over 3 or a pi over 2 of some sort when I reduced my pi over 6s. When I reduced my pi over 4s, what did I get? Only pi over 2s. And remember the pi over 2s, this is kind of a way to check your work all along the way. Okay? Now, how many of you, if I were to give a pop quiz today, no worries, I'm not going to. But if I were to give you a pop quiz and I handed out a bunch of blank unit circles, how many of you could, without a doubt, you could give me the full degree circle and you could give me the full radian circle, the positions? Okay, so either you can't, and that's fine, or you are too scared to raise your hand, and that's fine too. Okay, you have to be at that point by next Wednesday. Okay, now you do remember that I'm not going to see you on Monday, right? The next time I see you, you're taking a test. You remember that? Okay, so you have to have that circle backwards, forwards, frontwards. I mean, you should be dreaming about it. Okay, sorry, it's not a nightmare. Okay, but this should be something that you should be practicing. And guys, you can practice this with or without the circle. You can practice counting. That's all it is counting, right? You're counting by 30s, you're counting by 45s, you're counting by pi over 4s, and you're counting by pi over 6s. That's it. Okay? Make sure you've got it down pat. Now, this is the only test that I'm going to grade your unit circle. All of the other tests, I will give out a blank unit circle that you can use if you want it, but I won't grade what's on it. Okay, so this is the only test that I actually grade those unit circle values. Okay, I mean, like, are you, in Math 110, did you guys get tested on your addition facts? No. In fact, you're looking at me like I'm nuts, okay? Because you should know it so well that we don't have to test on that in Math 110. Okay, so every other test, that's what this is gonna be. You should know that unit circle so well that I don't have to test you. I'll just give you a blank one in case you feel like using it. Okay, you can fill it in if you want to. Okay, so that's how that's gonna work. Now, about the test, can you guys go ahead and get on my lab? Go ahead and get on my lab. And let's go ahead and go into the assignments. So what I want to point out first is the practice test. So can you just go into the practice test? All right, let's just look here for a minute. How many questions? 14. How many attempts do you have on this? Unlimited. Okay, that is not going to be the same as the test. You get one chance for the test. So a couple things on here. There's not 14 questions on your test. I'm still in the middle of writing it, so I don't know how many there are. Okay. But I think it's maybe 16. So it's not that 16 plus the unit circle. Okay. And I think I'm going to have to, I haven't figured out yet how to put the unit circle into my lab. So I think that that's just going to have to be a paper piece of your test. Let's go ahead and start the test. And I want us all to look at the first question that you get. How many of you have the same question I do? Or something really similar? It's a multiple choice question. Anybody? Madison, yours isn't multiple choice? It is? Oh, so you do have the same thing. Oh, you didn't raise your hand. So you do. Anybody else have the something really similar? Okay. Okay, it's Natalie, right? You do. Okay, so let me just say this first. I have very, very few, if any, multiple choice questions. Okay, so if I was looking at this, if this is one of the ones that I brought up as my first question, I would totally ignore the multiple choice. I would read the directions, find the center radius form with the center at 7, 8, whose radius is 3. I would totally read that. I would do my work, and then I would go and look at my choices. But you don't get really, attached to multiple choice, because it ain't gonna happen. Okay. So our first question, it might be multiple choice, it might not be. So some of you, I see you have little grids. Jaden, is yours a graph question? What's yours say? Okay, so she has to graph on hers. Is it Michelle? Michelle, right? I was wavering between Michelle and Priscilla, but I know it's your sister. So, Michelle, what does yours say? Because yours is not a graphing question, and it's also not a multiple choice question. So it's the same type of question I have, just without multiple choice, right? Okay. All right, here's the deal. I set this up as an unlimited number of times that you can try, because every single time you go and try it, you get a different test. The more times you try it, the more practice you get on what a possible question might be like on the test. Okay, so you might have a graphing question like Jaden's, or you might have a non-multiple choice question like Michelle's. Okay, so so the more times you work it, the more time. All right, so let's go. Can you go to? It won't. You have to answer it to get to question 2. Sorry. Okay, so so that's the first thing, is that the way I set it up is that the more times you work it, the more times you get types of questions that will be on your test. Okay? You don't know what they are, but if you've practiced them all and you're very familiar with them all, you're going to do just fine on that test. Okay? So that's the first thing that I want to point out. Second thing that I want to point out is that in years past, I haven't totally decided if I'm going to do this, but in years past, I have given a little bit of extra credit for getting an A, B, or C on the practice test. Okay? So, and when I say a little bit of credit, I'm talking about a little bit of extra credit. Okay? So if you don't do it, it won't hurt you. But the practice test is so helpful that it's worth it to me. And sometimes students have had to do the practice test 4 times before they get the grade they want. But every single time you go through, you're getting a different set of questions. And so you're just preparing yourself for the real test to come, okay? I would strongly recommend that you work the practice tests without anything out in front of you. Now, the first time that might not be doable. But guys, you're not going to be allowed to have any extra helps and notes out in front of you on test day next Wednesday. So the whole purpose of practicing is trying to put yourself in a real case scenario. Okay, so my suggestion is that you practice just like it's going to be on your test, your real test, with nothing out in front of you. Also, if I did give you a question like this, in other words, if I gave you a multiple choice question, and like I said, if I do, there's not going to be hardly any. But this goes for any question, not just multiple choice questions. Okay, here's a great example. I could totally see a multiple choice question where your 4 choices are, is this a circle A, B, is it an ellipse, C, is it a parabola, D, is it a hyperbola? I could see that. But then what am I going to expect you to write out for me? An explanation. Okay, so every single question pretty much needs to have work that backs it up. If you just pick C, but then you don't tell me why, or you don't have anything to back it up, I'm probably not going to give you credit. This might be a bad example. -7. I mean, it's D, and there really isn't much work to show, is there, on this one? This, I promise you, there's no multiple choice questions like this. The point is that I need to see your work. I've got to see your work. It needs to be organized. If I can't figure out what you're writing down, remember that I don't just have you, okay? I have over 75 students. I don't have the time to figure out what I think you might have meant, okay? So if I can't figure it out, I just mark it wrong and move on. So be clear, be organized, number your questions well, okay? So that I don't have to go searching. It is very frustrating when a student has, okay, here's number 1, Ms. Roberts, and here's number 10, and here's number 13, here's number 5. Are you serious? Now, I realize sometimes you'll forget to do a problem and it's out of order. I get that. But it shouldn't be the whole thing, okay? I did tell you I was going to include a formula sheet, with the 4 equations on it. That's it. Do you guys have any questions? I'm not thinking of anything right this minute. I feel like I've told you everything I wanted to tell you. Do you have any questions at all? Okay, so let's do this. You have two options. You can either start working through the practice test, or if there's still some homework that you haven't completed, some demonstrate sections that you haven't completed, you're welcome to work on demonstrate sections that you haven't completed, okay? Because they'll be due, I guess, on Sunday night. So, so that's the next due date. So either the practice test or some demonstrate sections. I'll be here. I'm walking around, seeing if you guys have any questions at all for me. Okay. You can work together if you want to, or ask each other questions. You don't have to be silent. Yeah.